Hello everyone. In this video, I'm going to talk about the UseReducer hook, which is one of the more complex React hooks, but I'm going to break it down step by step so you know how to implement this hook in any of your React projects. Also, if you want to take your React skills to the next level and learn everything you need to about React, make sure to check out my full React course, which I'm going to link down in the description below. Let's get started now. Welcome back to Web Dev Simplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this one. Now to get started, I have a really simple counter application on the left, and you can just see we have a simple state that defaults to 0, an increment and decrement button down here, which we have minus and plus, and as we click the plus button it goes up, and the minus button it goes down. This is a very simple application and a great example of how useState works. But useState is not the only way to manage state in React. There's something called UseReducer, which also allows you to manage state and re-render a component whenever that state changes. And the idea behind UseReducer is it gives you a more concrete way to handle complex state. So it gives you set actions that you can perform on your state, and it's going to convert your current state to a new version of the state based on the action that you send it. If you're familiar with Redux, the UseReducer hook has a very similar pattern to Redux. I just feel it takes away a lot of the boilerplate that's associated with Redux. So to get started, we're going to convert this counter application to UseReducer because this is a simple example that'll really demonstrate how the UseReducer hook works. So let's just import that UseReducer hook. And to use UseReducer, we come down here. It's going to return to us an array. And then we can just say UseReducer. And this reducer function is going to take two different parameters to start. We're going to have a reducer, which is a function that we perform on our state to get new state. And it's also going to have an initial value. So we're going to pass it a function, which we'll call reducer. We can define that up here, reducer, just like that. And then we're going to pass it our initial state, which in our case, we're just going to use an object, and we're going to set the count here to be equal to 0, just like that. And now this is essentially the same as setting up our state down here with a default value of 0. We could pass in 0 here instead of an object, but generally when you work with reducer and UseReducer, you're going to use objects instead of actual values, just because generally your state is more complex than just a single value. So we're going to use an object here just because that's most likely what you're going to run into. Now this return value is going to be two portions. The first portion is going to be the state. So in our case, this object right here. So we're going to call this a state, just like that. If we had set this to a single value, for example, just 0, then this would be our count. But in our case, we have it as an object, so we're going to use state. And now the second thing this returns is a function called dispatch. And this dispatch function is essentially what we call in order to update our state. Essentially, it's going to call this reducer up here for us, given certain parameters. And this reducer is going to take two different things. It's going to take the current state, so essentially where our application is currently at, and it's also going to take an action. This action is what we pass into this dispatch function. So whenever we call dispatch, what's going to happen is whatever we call dispatch with is going to get set to this action variable here, and then our current state is going to be in this state variable, and our reducer is just going to return our new updated state. So an example that we can take a look at would just be if we just did here, return count of state.count plus 1. Now every time we call dispatch, it's going to increment our count by 1. And let's get rid of all of this code down here, and instead of our increment, let's just call dispatch. We're just not even going to pass anything. We're just going to call dispatch, and then down here, we can put our state.count. And for now, decrement is not going to do anything. So if we save and we click plus, you can see we are incrementing our count by 1 each time, because every time we call reducer right here, which is our dispatch function essentially, we're taking our current count and adding 1 to it. Now obviously this is not a very useful example because this is a very simple use case and we're only handling one state. We're only handling our increment state. What happens if we also want to decrement instead of just increment? Well, in that case, what you do is you generally are going to pass a type into your dispatch. So here we'd pass an object with a type, and this would say, for example, increment. Just like this, increment. And then inside of your reducer, you're generally going to have a switch statement or some form of if statement in which you're going to just go over our action.type, and we want to check all of our different types. So our first case is going to be for increment. And if we are incrementing, then we want to return our state essentially added to itself plus 1, just like this. Our next case is going to be for decrement. So we can say decrement, whoops, if I could spell properly, there we go. And in this case, all we want to do is return our state -1 instead of +1. And then generally, it's a good idea to have a default case. Either here you can throw some form of error if you want, or generally, I just like to return our current state. Essentially, this is not a valid action. If we're not incrementing or decrementing, we just do nothing with the state, so we're just returning the state we already have. And that right there is our entire reducer function taken care of. We have our multiple different types. So essentially these types are like the actions that you can do on your actual state. So we're saying the only two things that we can do to our state is incremented and decremented. And then whenever we want to do that, we just call dispatch and pass in that type. In our case, increment. And for decrement, we would just do a type of decrement here. Now what's going to happen is if we save, we can click plus and increment and minus, and that's going to decrement our count. And we have no other way to modify this state other than through the actions that we have predefined. This is a great way to make sure your state only changes in ways that you expect it to and not in some weird unexpected way. Another thing that you'll notice is that we have these hard-coded strings for increment and decrement scattered throughout our code. This is generally something I really don't like, so what I do a lot of times is I create a constant variable. We're just going to call this actions, and we're going to put it in all capitals because this is a global, non-changing variable. And we're going to set it to an object, which is going to contain our different actions. So we're going to have increment is going to be set to the text increment. And we're going to do the same thing for decrement. We're going to set it to the text decrement. And then instead of using our hard-coded strings here, we could just say actions.increment. And down here, we could say actions.decrement. And then again, same thing down here. Instead of passing the string, we're going to pass in our actual string values for our object so we can have hard-coded values, and that way we have autocomplete. We don't have to worry about misspelling a string, because if we misspell something here, it's going to give us a warning or an error, especially if we're using something like TypeScript to type check all of this. So this is just a much safer way, in my opinion, to handle this incrementing, decrementing, and different action types instead of having hard-coded strings everywhere. Also, if I want to change our string, I could just change it here and it'll persist throughout our entire application without breaking anything, which is really important. Now, as I mentioned at the beginning of the video, UseReducer is really not that useful for small state like this counter. It's a lot of extra code to handle this counter, and it's really more important when you're working with more complex state or a lot of nested components that you have to worry about passing props down into. So let's take a look at an example of a really simple to-do application to show you how this can actually be used instead of a more complex use case and really show you the power of UseReducer. So let's essentially clear out a lot of this. We're going to take our reducer here, just remove everything inside of it, get rid of all these actions because we're going to have to-do related actions. And then inside of our state here for our app, we're just going to have to-dos. And instead of doing an object here, we're just going to use a simple array because we're only going to have one thing in our state, so we don't actually need that object. Let's get rid of these functions here, just like that. And then down here, we can actually set up the code for our form, which is going to be for our input. So let's have a simple form with a simple input type of text. Value, we're just going to set equal to name, and on change, what we're going to do is we're just going to set a variable to be that name. So we can say set name is going to be equal to here, whoops, e.target.value, and close off that input. And we want to make sure we actually bring in that state. So we're going to have name, set name. That's going to be use state with an empty string, and we're just going to import use state up here. There we go. We should have an input over here, and we can change it, and that's going to update our name variable right here. The next thing I want to handle is what happens when we submit our new to-do. So we can just say handle submit. Let's just create a function up here for that. Handle submit. And inside this handle submit function, all we want to do is add a new to-do. So we could say dispatch, and we're going to have a type here, which is going to be for our new to-do. So let's create that action up here, new to-do. We'll actually just call it add to-do. We'll say add to-do. So now we can say actions dot dot add to do, just like that. And then we can set our name back to an empty string, which is going to clear out our name. So if we just save, type something, hit enter, you can see it clears out our name, but it's refreshing our page. So let's just make sure here we do e.prevent default. That's going to prevent our page from refreshing. Now if we type, hit enter, you can see everything is working perfectly fine. It's clearing out our input, but obviously our reducer is not doing anything with this add to do. So up in our reducer, let's get that switch statement back. We want to switch on action.type. And the first thing I want to check is going to be that actions.add to do. And what are we going to do when we add a to do? Well, we need to take our current state, which is all of our to-dos, and we need to put that into an array. So we're going to say to-dos, because this is actually all of our to-dos instead of state. So this is all of our current to-dos. And then what we want to do is we want to add on a new to-do. So we'll just say new to-do. And inside of here, we need to pass some form of name variable to this new to-do. And then we can create a function called new to-do, which takes in a name, and we can just return our new to-do. So our ID is going to be date.now. We're going to set our name equal to our name, and complete is going to be false, because if we create a new to-do, obviously it's not complete yet. But you'll notice immediately one problem. Where are we getting this name from? We have it here where we've set our name to this name variable, but we don't have access to that inside this reducer function. So something that you commonly are going to do with reducers is you pass in the type, which is going to be the thing that you want to do, and then you're going to pass in what's called a payload. This can be named anything. I'm just showing you the common conventions. And this payload is an object which essentially contains all of the variable values we need to actually perform that action. So in our case, we need to pass in a name. So we're going to pass in a name, which is equal to our name here. Now we have our action.payload.name, which is going to be equal to the name that we have set to this name variable here, which is inside of our input. And then it's going to add a to-do to our list. And if we just come down here and console.log our to-dos, and if I inspect the page, bring this over so we can see the console, and I type something in and hit enter, you can see it adds a new to-do for us, and it contains the name of whatever I typed in. We have our ID, and complete is equal to false. So I want to just reiterate what happened here, because this is really the magic of the UseReducer function, is this type variable is getting passed in to our dispatch, which is essentially what we're going to do, and then we're passing in this other parameter, which is our payload, and this is what the parameters essentially are for the action that we're performing. So instead of having a bunch of different callbacks, one for adding a to-do, one for editing to-dos, completing to-dos, deleting to-dos, we just have one single function, dispatch, and it takes in different actions and different parameters based on what you actually want to do. So let's take a look at another example, which is going to be for completing a to-do in our list. We can just say down here, case actions.toggle, toggle to do. Let's make sure we put that up here. Toggle to do, just like that. And this is going to be our action for either completing or uncompleting our to do. So essentially marking it complete or not complete. And come down here. First, let's print out our to-dos. So we can loop through all of our to-dos. So we can say to-dos.map, each one of our to-dos. And I just want to create a to-do component. So we'll say to-do, going to have a key, which is equal to to-do.id. And we're going to pass down the to-do as well, just like that. So let's create a new file called todo.js. And if you just type rfc for this, you can create a function component. And that's because I have an extension installed called ES7 React Redux GraphQL React Native Snippets. It's really helpful if you don't want to type out a boilerplate component every time. So now with that out of the way, we have our basic to-do here, and it's going to take in a to-do. Now inside of our to-do, we're going to have a span, and this is going to contain our to-do.name, just like that. And we're also going to give it a style. And this style is going to be what happens if it's complete or not complete. So we're going to set the color based on to-do.complete. And if it is complete, we just want it to be this really light gray color. And if it's not complete, we're going to make it completely black, just like this. There we go. Let's put this on a new line so it's a little easier to read. There we go. And then we're going to have two different buttons. And our buttons are going to be for toggling our to-do and completing. So we're going to have toggle and delete here. And we don't really know how we're going to handle the on click for these buttons yet. So let's just leave them like this for now. We're going to save both of these. And of course we got an error because we need to import to do. So come up here, we'll import to do from /todo.js. And again, we're getting another error. And that's just because down here, we need to make sure we return this from our map. And now if we save, we should see that if we type something in, hit enter, we got that added as a to-do. We can type something else in. And again, we're getting that added as a new to-do. Now all that's left is to handle our toggle and delete functionality. So let's write in our toggle functionality inside of our reducer. So what we need to do is we need to take all of our current to-dos and we need to map over them to get a new list of to-dos. And we need to take the current to-do that we've toggled and set that to complete or incomplete depending on what it currently is. So we can just say we're going to have each one of our to-dos. And here what I want to do is I want to take a check to see if our to-do.id is equal to the current ID. So let's pass that in through the payload. We can say action.payload.id. And if that's the case, I want to get a new to-do that is complete. So we're going to take our current to-do and spread it out so that all of the values in our to-do are in a new object. And then we're going to set complete equal to to-do.complete, but we want to negate this. So it's the opposite of to-do.complete. So this is essentially going to reverse the polarity of our complete flag, turn it from true to false or from false to true. And if it's not equal to the current to-do, let's just return the to-do as is because we don't want to modify it. Now what we can do is we actually know how to set up this toggle to-do. We need to pass in to our dispatch function this action, as well as a payload that contains the ID of the current to-do. So a really easy way to do that is just pass our dispatch function down into our to-do here. And we're going to set that equal to dispatch, just like that. And now on our to-do, we have access to dispatch. And now what we can do, instead of our button, is we can say on click. What we want to do, call a function. We want to call this dispatch function, and we're going to pass it in a type, and we're going to pass it in a payload. And our payload we already know is just going to be our to-do.id. We're just passing in our ID as an object, but our type is going to be a bit confusing. It's going to be actions, and we want to make sure we get our actions.toggle to do. And in order to get this actions object, we can just import that. So we can say import actions from /app.js. And let's make sure we export that all the way up here. So we can say export our actions. And now we are able to toggle our to-do. Let me just make this screen a little bit larger so it's easy to see. So we're calling an onClick function, which calls our dispatch with the toggle to-do type, and it gives us the ID of the current to-do inside of the payload. So now if I type something in, type something else in, hit toggle, you can see that it now has that light gray color because we toggled it to complete. We click it again, it toggles to incomplete, and we can do this for both of our to-dos, completely independent. And again, we only ever passed in that one single dispatch function into our to-do here. We can do a very similar thing with our delete. Let's just copy all of this, paste it into our delete here, and instead we're just going to call delete to-do, and again, pass it in our ID. Now in our app, let's handle that delete to-do. We can say delete to-do. It's going to be delete to-do. And again, we're going to have a case for deleting our to-do, just like this. Get our indentation correct, and also make sure we put in our default case, which is just going to return our current list of to-dos. So now here, if we delete a to-do, all we want to do is take our current to-dos, we want to filter them to remove the to-do that we don't actually want, the one we're trying to delete. So we can just say to-do, and to-do.id is not equal to our action.payload.id. So essentially what this is saying is if the ID of our to-do is not equal to the payload ID, then we keep it, otherwise we get rid of it. So it'll delete whatever to-do we want to get rid of. Now we can put in some to-dos here, and if we toggle them, that's working as expected, and when we click delete, it's going to remove that to-do from our list. And the brilliant thing about this is no matter how many different actions we want to support for our to-dos, for example, if we want to edit them, if we want to save them, if we want to share them, move them somewhere, do all these fancy things, all of that is inside of our one reducer function. And when we pass our stuff down to our to-do, we just need to pass this one dispatch function, and that handles all of our different use cases. So no longer do you need to pass in handle click, handle complete, handle edit, handle new, handle create, handle delete. You just pass in dispatch, and that is it. It really cleans up your props and in general makes the code that you're working with much easier and cleaner in my opinion. And that's all there is to the UseReducer hook. If you enjoyed this video, make sure to check out my complete React course, which covers everything you need to know about React. I'll link that down in the description below. And also, thank you very much for watching this video, and I hope you have a great day.